Okay, today we talk about our last chapter. We'll start our last chapter, and it's about graphings and lines. And in section 3.1, we're going to talk about the coordinate plane. Now, the coordinate plane has a couple of different names. It's also known as the XY plane. So a plane is a two-dimensional object, as opposed to a line. It's also known as the Cartesian plane, after Rene Descartes, who invented the plane, actually. Okay. Now, when we start talking about the coordinate plane, because it's two-dimensional, we also start talking about things called ordered pairs. Okay, ordered because the order matters, and a pair because there's two of them. Okay. Ordered pairs are how we're going to determine locations on the coordinate plane. Okay. Now, So A comma B. Now A, the first one, is going to be known as the x-coordinate. And the second one, B, is known as the y-coordinate. Okay? So we will always take this to be true, x first and then y. Okay? So when you superimpose or place two straight lines at 90 degrees with each other, you've created a two-dimensional object. Okay? The horizontal axis is known as the x-axis, and the vertical axis is known as the y-axis. Where they meet is the point 0, 0. I'll explain this in a moment. And this is called the origin. Alright, now what we're really thinking about here is we're thinking about two number lines, where this is positive infinity and this goes to negative infinity. If we go up, then the positive infinity is here, and downward gives you to negative infinity. Okay, so it's two separate number lines. All right. Now let's say we had to graph endpoints here. Okay. So with the point negative 2, 4, what that's saying is first we'll go negative 2 in the x direction, and then we'll have to go up positive 4 in the y. So over negative 2 and up 1, or up 4, sorry. So this is negative 2, 4. So that's our first one. Now our second one, 5, 1, says we'll go out 5 in the x direction, and then up 1 in the y. So this is the ordered pair 5, 1. Okay, that's its location on the coordinate plane. If we had to graph 2, negative 3, we would come over 1, 2, and then down negative 3. Now this point, 0, negative 2, now the origin is called the origin because you go nowhere in the x and nowhere in the y, 0 and 0. Now this one says we're going to go nowhere in the x, we'll stay exactly where we are, and then up 2 in the y. This is the point 0, 2. For this one, we could go over negative 1 in the x and then down negative 4 in the y. And lastly, we have this one, negative 3, 0. So this one says we'll go to the left to negative 3, and then nowhere in the y. So this is the point negative 3, 0. So notice that this point 02 here in purple lies on the y-axis. Okay. Now that's just what I picked. Okay. But if a point is going to lay on this y-axis, what we absolutely have to have, let's see, any point on the y-axis must have a coordinate that is equal to 0. Because if I move left or right, I have moved off the axis. Now this point also lies on the axis. It lies on the x-axis. And any point on the x-axis has to absolutely have a y-coordinate of 0, because if I move up or down, I'm no longer on the or the x-axis. So this is two very important points to remember. Okay? Which one equals 0? Okay. Now, notice again I've drawn the coordinates here, the axes, and this makes up the Cartesian plane. It's a symbol of it. And it breaks it into 4 different parts. Okay. Now, the way we normally label this is with Roman numerals. Okay, these 4 parts are known as quadrants. We see the word quad in there, the prefix quad, meaning to break into 4. So this is quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. Okay, using our Roman numerals. Okay. And each of these quadrants has some special characteristics. Okay. Now, before I go on and explain that, okay, there's something that we should note here. One way to express the fact that a number is positive, okay, is to say that it is greater than 0. Okay. We know this. Here's our number line. Here's 0. We know over here is positive numbers. Okay, so we would say that anything over here is greater than 0. Okay. And then down here is the negatives. Okay, so if we want to express negative numbers, we would say that it's less than 0. Okay. Alright, so now remembering these are number lines that extend in each direction, here positively, here negatively. Okay. So if this is the x-axis, if I'm going to be in this quadrant, I would need to go positively in the x. Or if I went positive in the x but negative in the y, I would be down here. So in this quadrant, positive x, and now positive y. Remember, this is positive as well, and this is negative. Where in this quadrant, y would be less than 0. Okay, the y coordinates there. Remember, this is quadrant 1, so this is why it's quadrant 1, because everything's positive. We like it. Okay. Now, if I'm going to be over here in 2 or in 3, well, looking at ordered pairs, I would have to go negatively in the x. So x is less than 0 here and here. So I'm going negative in the x. Now, if I want to be in quadrant 2, I have to have y values that are positive. Remember, this is the point 0, 0. Okay. And to be in quadrant 3 now, I would need to have y values that are negative. Okay, so with that, let's figure out if we can determine which quadrant these lie in. Okay. So this one has a negative x, so I'm going over here. My options are 2 or 3. But y is positive, so it turns out I'm in 2. For this one, both x and y are positive, so positive, positive puts me in quadrant 1. Here, we have a negative, negative, so I'd have to go negative in the x and negative in the y. That puts me in quadrant 3. Now for this one, I have a positive x, so I can either be in 1 or 4, but the y is negative, which means I'm in 4. Now remember that some points will not lie in the quadrants. If they lie on these axes, they are not in any of the quadrants. Okay? So if I've gone nowhere in the x, and then down 3, I must be on the y-axis. With this one, I'll go positive 5, but then nowhere up or down, so I must be on the x-axis. And the point 0, 0 lies on both. Okay, it is the intersection of the two. All right. So that's what the quadrant is, all right? And we might care then to find out about distance, all right, between 2 points. All right? So in this one, let's plot 1, 3. Okay? So x1, y3. And then the point 2, 6. Okay? Everyone get used to labeling your points. Okay? Now, I'm concerned about finding this distance. Okay? We can do that. That won't be a problem. So notice, if I extend the horizontal line this way and a horizontal line down, when I do that, I've formed a triangle. Okay? So, and specifically it's a right triangle. So specifically, if I knew this side and this side, I could determine this one using Pythagorean theorem. Okay? So let's find out that distance. Okay? So how far is it that the length of this side is? Well, I move from 1 to 2, so the length of this side is just 1. Now on this one, I move from 6 to 3, so the length of this side is 3. Okay? So I've changed from a y-coordinate of 6 down to the y-coordinate of 3. So I know the length of this side is 3. Now from here, the way we determined that is we started at an x-coordinate of 2 and then went to the x-coordinate of 1, which has a length of 1. Okay? All right. So now we can determine this. Okay? So we know by Pythagorean theorem then that 1 squared plus 3 squared should be equal to the hypotenuse squared. Okay? We'll call our hypotenuse distance, d for distance, because that's what we're looking for. And now we can just solve 1 plus 9 is equal to d squared, or that 10 is equal to d squared. So that if I take the square root, remember I'll add plus or minus for the distance, okay, to solve for d. But distance is always positive, so we'll take the positive branch here. So the length in between these 2 points is square roots of 10. So this is an example to help you understand where the distance formula comes from. This is the distance formula. You will need to know this. Okay, so put it on your flashcards. It's the same thing as the Pythagorean theorem. So just like I did up top here, I'm going to look at the x values. Okay, so the distance between here and here is, I'll take the x2 value and I subtract from it the x1 value. That's the length of this side. Just like here I had 2 minus 1, here I'll just take x2 minus x1. Now on this one, I changed from a y value of 2, of y sub 2, and we subtract y sub 1, the other y value. So from here I went from 6 minus 3 to get 3. So now, and we'll call this d again. Okay? So now we know that this side, x2 minus x1 squared, plus this side, y2 minus y1 squared, has to be equal to the hypotenuse, which is distance squared. Okay. So if we solve for d, we just simply have to take the square root, x2 minus x1 squared, plus y2 minus y1 squared. Remember, there would be a plus or minus, but distance is always positive, so that's why we don't have the plus or minus outside of here. Okay, now let's find some distance between points. Okay. All right. So, for example, our first point is 1, 3, and our second point is 2, 6. Now, this is exactly what we did before, but let's use the distance formula now. Okay. Now, it doesn't matter which way you call these, but I always label them. So x1, y1, because it's the first one given, Let's call this one x2, y2, because it's the second one given. Okay. Now, also, if you write down the distance formula every single time that you do a problem, it'll help you memorize it. Okay, so distance is the square root of x2 minus x1 plus y2 minus y1, and those quantities are squared. So, this is the square root of, okay, so x2 is 2, okay, then minus from the formula, x1 goes over here, 2 minus 1, okay. Now we have to square that. Okay. Then, for our next one is y2, so this is y2, 6, and now minus from the formula, y1, which is 3. And then we have to square that. So this is equal to, now we'll simplify underneath the radicals. 2 minus 1 is 1. That's still squared. 6 minus 3 is 3, and that's squared. So this is just equal to the square root. Well, 1 squared is 1. 3 squared is 9. So this is just equal to the square root of 10. Which is what we found before, using the Pythagorean theorem in the diagram. Now, here we're going to have to be careful. Let's look at the next example. -3, 2, and -5, -1. So we're going to have to be careful with our negatives here. Okay? Again, let's label them, x1, y1, and x2, y2. Then we know distance is equal to the square root of x2, x1, x2 minus x1 squared plus y2 minus y1 squared. Okay. And now we can just fill it in. X2 in this case is -5. Okay, so remember the parentheses, and then I put in a -5. Now I'm going to subtract from the formula, and then I have to subtract x1. Okay. And x1 is -3, so I have to put it in parentheses. Okay. Then close the parentheses and square it. Plus, now, y2 is -1. Okay. Then minus from the formula, y1. Okay. In this case, y1 is 2. And then that quantity needs to be squared. Okay. Alright. Now, let's simplify inside of here. This is -5. Okay. Now, what happens here? Remember that when you're subtracting a negative, that turns into a positive. Okay. And then plus, well, simplifying into parentheses, -1 minus 2 is -3. And that gets squared. So this is equal to -5 plus 3 is -2 squared. And I'll just copy the -3 squared while we're here. Okay. So now everything inside these parentheses are simplified. Keeping the square root, -2 squared becomes a +4. -9 squared, -3 squared becomes +9. So in the end, this is just the distance between them is square roots of 13. Okay, let's try another one. Now, for example, we could have ordered pairs 1, square root of 2. That's fine. This is an irrational number, but even irrational numbers are on the number line. And the square root of 2, +1. Alright, that's fine. Let's label it x1, y1, x2, y2. So now distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so let's do that. So distance is equal to the square root, parentheses. Now, x2 is the square root of 2. Now minus, from the formula, x1. Now x1 is negative, so I'm going to put that in parentheses. Now that we close and square from the formula. Then we add and open up. y2 is 1. Then minus from our formula. Then y1, which is the square root of 2. And that needs to be squared. Okay, let's simplify this. Let's see, x2, okay. So this is the square root of the square root of 2, and then we have the 1. But remember, when you're subtracting a negative, that becomes positive. And then this is as simplified as we can get inside. Okay, so this is going to take a little bit of work. We need to simplify these, so we have to square them out. Okay, so remember, this means the square root of 2 plus 1 times the square root of 2 plus 1. And then we add, and this means 1 minus the square root of 2 times 1 minus the square root of 2. Make sure your division bar or your radical bar goes all the way over. Okay, now let's FOIL this out. Okay. Alright, so the square root of 2 times the square root of 2 is 2. Plus the square root of 2 plus another square root of 2 plus 1. So that's this. And then plus. Now here we'll also FOIL this one. Okay. 1 times 1 is 1 minus the square root of 2 minus another square root of 2. A minus and a minus become positive, and the square root of 2 times the square root of 2 is 2. Now, all of this is under the square root. Okay. Now, let's see if we can combine some like terms here, okay? So, here we have 2 plus 1, which is 3, plus another 1 is 4, plus 2 is 6. Right. Yep, 2, 3, 4, 5, 6. Okay, so 6. And now, here I have plus the square root of 2, plus another one is 2 square roots of 2, but then I'm going to subtract away 2 square roots of 2. So these equal 0. So I'm just left with the square root of 6. Okay, now the next one's going to take a little bit of work. All right, we're going to have to use the distance formula. Okay, they want us to prove that negative 3, negative 1, 1 comma 2, and 7 comma negative 6 are the vertices of some type of right triangle. Okay, I don't know which way it's oriented. Okay, but the vertices are these corner points. Well, how are we going to do that? Okay. Well, what we'll need to do is that we'll need to find, let's label these points so it makes a little bit more sense to us. Okay. And I'll arbitrarily label them here. Let's say this is A and this is B and this is C. I know it doesn't make any sense. Let's see, which quad? Let's do one that's a little more. Okay, so this one's in quadrant 3. This one's in quadrant 1, and this one's in quadrant 4. Okay, so it could look something like this. Okay, I'm not exactly plotting them, but something like this. Because we'll see the math is the only thing that matters here. So this is point A, this would be point B, and this would be point C. Okay. So what we would need to show if this is a right triangle is that the sum of two sides is equal to, okay, so this side squared plus this side squared would equal that side squared. Okay. Alright, so let's do this. Let's find the distance between A and B. So that line segment between A and B. Okay. For that, we're looking at the point -3, -1, and 1, 2. Okay. All right, so if this is x1 and this is y1, and this is x2 and this is y2. Okay. Remember, this is just a sketch to help us understand. Okay, we know this. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now let's fill it in. Right. So in this case, x2 is 1. Okay, so this is the square root of 1. Then we minus from the formula, and x1 is -3. Then we close the parentheses and square that, and add to it y2, which is 2, minus from the formula, and then y1, which is -1. Okay. Then we can close the parentheses and square that. So this is equal to the square root of, now let's simplify in here. Okay. Subtracting the negative becomes positive. And then we'll add, and again the same thing will happen here. Subtracting the negative will add. Okay. So this is equal to the square root, 1 plus 3 is 4 squared, 3 plus 1 is 3 squared, which is the square root of 16 plus 9, which is equal to the square root of 25, which is equal to 5. Okay, so now we know the distance between A and B. Let's now find the distance between A and C. Okay, so from A to C, that line, A starts at -3, -1, and C is 7, -6 as we play with it. So we'll call this one x1, this one y1, this one x2, this one y2. Okay. Now we know that the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so this is equal to x2 is 7, so parentheses and then 7. Now minus from the formula, x1, which is -3, so we're subtracting the -3. Then we'll close that parentheses and square that, and add to it y2, which is -6, subtracting from the formula, and then y1, which is -1. Okay. Right. Now we need to simplify inside. So the square root of 7 -6 and +1. Okay. Now remember, in both of these cases we're subtracting the negative, so this becomes plus. Okay, so this is equal to the square root of 7 plus 3 is 10 squared, plus -6 plus 1 is -5 squared, which is equal to 10 squared is 100, and -5 squared is 25, which is equal to the square root of 125. Which we could reduce, but for this problem we'll just continue. Okay. All right. So that's the distance between A and C. And we know the distance between A and B, so we just need to find the distance between B and C. Okay? And for that we're using B, which is 1, 2, and C, which is 7, -6. Okay. So again, we'll label it out. This is x1, y1, x2, y2. Okay. And we know that distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So here we go. X2 is 7. Right, so we're going to have 7 minus x1, which is 1. Close that parenthesis and square it, plus y2, which is -6, then minus from the formula y1, which is 2. And that'll get squared. So this is the square root of 7 minus 1 is 6. That needs to be squared. -6 minus 2 is -8 squared. 6 squared is 36. -8 squared is positive 64. So this is equal to the square root of 36 and 64 is 10, carry the 100. Square root of 100, which is 10. Okay. Alright, now we've done the first things that we need to do. That is, we found the length of the sides. So, AB was equal to 5. I'm just going to rewrite these down again. And AC was the square root of 125. And BC was 10. So now we need to find out if A squared plus B squared is equal to C squared, remembering C is the longest side. So which of these is the longest one? Well, if you're not sure, you can just look back at the square roots. AB was the square root of 25. That is certainly smaller than the square root of 100. And the square root of 125 is larger than the square root of 100. So we know that our C then is 125. Okay, so if that's squared, and then it doesn't matter which one we call A and B. So we will test. Okay. Alright, well, 5 squared is 25, 10 squared is 100, and the square root of 125 squared is 125. And from here, we can see that these two are equal, and therefore, these are, we'll write our conclusion, these are the vertices of a right triangle. Okay, and so we'll make our conclusion. Okay. So that's how you perform that problem. Okay, so now let's try and draw a picture for the next one. They want us to find 2 points on the x-axis that is 5 units away from the point 1, 2. Okay, so here's 1, 2. They want us to find 2 points. I don't know where they'll go, here and here possibly, but so that the distance between these 2 points, so 1 point here and 1 point here, is 5. Okay. Now, these points will lay on the x-axis, so I don't know what the x values will be. Let's call this one x2, but I know that the y value has to be 5, or I'm sorry, 0, if it lays on the x-axis. I don't know, we'll call this one x1, comma 0. So how are we going to determine these points? Well, I know how to do it if I just had this. Let's just look at the positive branch. Okay, if I had to look at the distance between the point 1, comma 2 and x2, comma 0, well, I know one thing. I know that distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, but I know this distance is 5 because we've said that. So 5, and then the square root. Now x2, I don't know what it is. That's unknown. But I know that x1 from here is simply 1. That's squared. Then plus y2. Well, here's y2. I know that to be 0. Then here's y1, which is 2. Now, let's continue to solve this. So I'm looking for x2. Plus 0 minus 2 is minus 2 squared. So this is 5 is equal to the square root of x2 minus 1 squared plus negative 2 squared is 4. Okay. Now that we know that, our goal is to solve for x2. Okay. So everything's as simplified under this radical as we can get. Now, I need x2 is underneath that radical, and I need to get it out. So to do that, I need to square both sides. Okay. So on this side, we'll have 25, and on the other side, the radical will be undone, and we have the quantity x2 minus 1 squared plus 4. Okay, now we're still trying to get to x2. Right? So let's subtract this 4 off to get 21 is equal to the quantity x2 minus 1 squared. Okay, so now this is just like what we did when we were completing the square. Right? Let's take the square root of both sides. So we'll get plus or minus square roots of 21. But that's just equal to x2 minus 1. So now if I solve for x2, I simply have to add 1 to both sides. So we'll get 1 is equal to plus or minus the square root of 21. Will be equal to x2. And it didn't really matter. Oh, sorry. Can you see? So now it doesn't really matter what I called this, if x1 or x2. This one will be 1 plus the square root of 21, comma 0. And the other one will be the 1 minus the square root of 21, comma 0. Okay. So I could have just called this x and then made it either way. So I hope this makes sense. In this case, you're going to take the distance and plug in, you know, the fact that it's on the x-axis, so y must be 0, and then solve, and the other two will come out. Okay. So that's how you do that one. Now, the other thing we care about is not just the distance between 2 points, but we'll care about the midpoint. Okay. So the last thing we have to talk about with the midpoint is here. Okay. This is the formula for the midpoint. Okay. This is also something you'll need to know. And what we're doing here is we take the x1 and we add x2 and divide it by 2. So anytime you're doing that, when you sum up a list and divide by the number in the list, you're taking the average of the x coordinates, and then you take the average again of the y coordinates. Okay. Alright, let me do this on a little bit bigger piece of paper. Okay. So, for example, we have the point -3, 2 and -5, 5. Okay. This is x1. We'll call this one y1. Call this one x2. Call this one y2. Okay. Now the midpoint is an ordered pair. So ordered pairs. The first coordinate is going to be the x-coordinate. You take the average of the two x's. And for the y-coordinate, you also average the y's. So in this case, our ordered pair, dividing by 2, we're going to add because we're averaging. Okay. Now, x1 is negative 3. x2 is negative 5. y1 is 2, and y2 is 5. And now we can just simplify it. So this becomes negative 3. Now remember, a negative and a positive become negative. Okay, so this is negative 3 subtracting 2. And 2 plus 5 is 7. So this is equal to negative 3 minus 5 is negative 8 divided by 2 over 7 halves, which we could also simplify as negative 4, comma, 7 halves. So this is our midpoint. Okay, we have one last one to do. Okay. Involves irrational numbers again. So now we're trying to find the midpoint of 1 minus the square root of 2. Okay, so that's an irrational number, comma, the square root of 2. That's also irrational, that's okay. And 1 plus the square root of 2. This is an entire irrational number, and a negative square root of 2. Okay. So we'll call this one x1 and this one y1. This is x2, this is y2. Okay. Now the midpoint is an ordered pair. Okay. So it's going to have an x-coordinate, and the x-coordinate is the average of the two x's, and the y-coordinate is the average of the y's. So now, let's fill this in. Okay, so it's an ordered pair, it's an average, there's 2 items in the list, we divide by 2, and we're adding everything up. Alright, now, x1 is 1 minus the square root of 2, x2 is 1 plus the square root of 2, y1 is the square root of 2, and y2 is negative square roots of 2 over 2. No, negative square roots of 2, sorry. Okay, now let's simplify this. Okay, now if I collect like terms, I have 1 plus 1 is 2. Minus square roots of 2 plus square roots of 2 go to 0. So 2 over 2. That was very nice. Now remember here we get the square root of 2 and we have the square root of 2, but adding a negative is the same thing as subtracting. Okay. So this is equal to, well, 2 over 2 is just 1, and here we have 0 over 2, and that can be simplified. Well, 0 divided by 2 is just 0. Okay. So this is our midpoint. Okay, so you might want to do your homework while you're watching the video and have it playing along so you can understand what's happening here. All right, when you have a question, send me an email.